Good morning to one and all present here. Today, in the lecture series of the course Strength of Materials, we will discuss a very important concept. We all know all the structural members that is supporting our day-to-day life, starting from infrastructure and roads, everything, bridges. So there exists a load, in turn, there exists a stress. Okay. So what will be the term that is associated with beams, or what will be the terms that is associated with all the structural engineering? There are two key words. That is, one is shear force and the other one is bending moment. So this presentation provides an overview of shear force and bending moment, key concepts in structural engineering. We will explore how these principles are applied in the real world scenarios and their impact on structural design. So understanding the beam types and loading. So we have four major beams that are categorized based on their structure. One is simply supported beam. So simply supported beam is nothing but a beam which has supports at both the ends and it is free to rotate. So all our bridges, overhead bridges, flyovers is made up of simply supported beams. And the second one is cantilever beam, fixed at one end, free at other end. So the best example for cantilever beam is a springboard in a swimming pool. A person standing on the swimming pool tries to dive into the pool by jumping from the springboard. That is, one end is fixed, the other one is not fixed. The third one is overhanging beam. It extends beyond its supports. Okay. So overhanging beam is the length of the beam extends beyond the support so that there exists a bending moment. The final one is fixed beam, supported at both ends, restrained against rotation. So it cannot rotate and both the ends are fixed. So what is the definition of shear force? Visualizing internal forces as per the definition. Shear force diagram shows the variation of shear force along a beam. We have certain sign conventions. One is positive shear force causes clockwise rotation to the left of the section, and the anti-clockwise direction will have a negative sign. So there is a procedure to calculate shear force at different sections of the beam and then represent it in a diagram. So bending moment diagrams, understanding beam curvature, where the beam has maximum bending moment, there exists maximum support to be provided. So it shows the variation of bending moment along a beam. Positive bending moment causes the beam to bend concave upwards. Calculating bending moment at different sections of the beam and then drawing the diagram. So connecting the dots, mathematical relationship, shear force is the derivative of bending moment, that is dm by dx. And maximum bending moment, the point of zero shear corresponds to the maximum bending moment. Where there is a zero shear force, there is a maximum bending moment. And SFD and BMD for common load cases simply supported with central point load, cantilever beam with end point load, simply supported beam with uniformly distributed load, cantilever beam with uniformly distributed load, simply supported beam with linearly varying load. So real world applications and examples: analyzing shear and moment in bridge beams under traffic loads, designing beams to support floor loads in buildings, calculating stresses in the shafts due to bending moments in the machines, analyzing shear and moment in crane beams under lifting loads. These are all the major applications of the Yes, shear force and bending moment calculations. And the key takeaways are understanding shear force and bending moment is crucial for engineers in designing safe and reliable structures. Utilizing shear force and bending moment diagrams as a powerful tools in analyzing structural behavior under various loads. So with this, we are at the end of the lecture. We'll meet you in the next lecture series. Thank you all.